Over the next few videos, we are going to introduce you to the cloth system available within Unity. And for these videos, I've actually stepped aside and I'm going to pass control back off to Lee, who's going to be doing the primary, he'll be doing the bulk of the driving, really.
Yeah, I'm back in the driver's seat.
Yep, and I'll be asking all of the questions and playing the part of the student once again.
All right, what I want to do in this first video is let you know or show you some of the things that I've got set up that we're going to need for the next couple of videos. The main reason we have to do this is because the way the cloth system works in Unity is we can't use any of the primitive objects that come with Unity for building our cloths.
Now, why not?
Well, we don't have direct access to any of our meshes. If I were to create a empty game object, hitting Control-Shift-N, and if I were to come up to Component and Mesh, well, actually, I can't do it from there. Let's do Create and create a...
Oh, you want to create a piece of geometry first, and
exactly. Then... So if I create a cube...
I know where you're going.
We've got a cube mesh, but we have no access to it other than through creating the primitive.
Right, that's internal.
Exactly. And since we can't get access to these meshes, and the cloth system requires us to have a mesh to turn into a cloth, we have to get those meshes from somewhere.
Okay.
So what I've done is gone ahead and created some very basic meshes inside of Maya that I've already brought in as FBXs.
So in this video, you're going to show us those meshes. What else are you going to be doing in this video?
Well, there's another interesting problem. Let me throw in these meshes, and I'll show you what these
By all means, sir.
The very first cloth that we're going to create is going to be just a very simple triangle-shaped flag.
A little pennant flag.
Yeah, so there's my little flag that we're going to create. This will be our first cloth that we mess with. And then after that, I want to do a little beach ball. There's a little example that we can do with, creating a soft body. So we're going to do that, but I needed a sphere. So
can you move that flag a little higher in the air so we can at least see it against the background?
Right.
Because we have this really high contrasted light level here.
Yeah, I can.
There we go.
Do that
just so we can see him against the sky.
Right. So we've got our little pennant flag, and I'll bring this up over here, and then I've got our little beach ball, and then I've got just a sheep. This is just a plain, nothing fancy that we can use.
Now, I would like to point out that for the sake of this example, Lee has brought in some geometry that is extremely dense. And for the purposes of a game, you very likely wouldn't want to use geometry that was quite this heavy in terms of vertices.
Well, there's a reason why they're dense. And the reason they're dense is because we're using cloth.
Yes.
So the more vertices that we have inside of the geometry, the better the cloth simulation is going to work.
Absolutely. And you're going to end up with a simulation that looks really, really good.
But again, it is a game. You have to use this technique sparingly. You don't want to create, let's say, a castle scene with waving pendants all along the castle walls.
Banners and tapestries.
Right. You're going to bog down the system.
Sure. And even if you wanted to, you'd want to make sure that generally for most game situations that your geometry is going to be a lot lighter than what you see here. I mean, if you've played any game, and these can be games that have been out for years, or even modern games. Like just the other night, I was playing Assassin's Creed Brotherhood, which at least at the time of this recording is a fairly recent game. It only came out a couple of weeks ago. And there's some cloth in that you can pass through, and it's not the most realistic cloth ever. I mean, when you bump into it, you can tell that it's been greatly simplified in order to work for a game.
It's probably a quarter of the... even less of the number
I'm sure
of
it's
vertices
far less dense than what we're seeing here. And I just want to mention that. This is a technical demonstration of cloth, not necessarily an illustration of the number of vertices you should be striving for in your own cloth simulations.
Right. I'm not recreating Italy here, so I'm okay
with
this.
Right. This is just to make the cloth system look good. Just wanted to throw that out, make sure there was no confusion.
Right. The other thing, though, is with just this geometry, I can demonstrate the other asset we have to bring in and why we have to bring it in.
Okay.
We have a series of objects that, just like the primitive objects that come with Unity, are using the built-in shaders, which means they're one-sided.
Right. If we try to flip around to the negative side of them, we can't see them.
Yeah, we no longer see the back faces. Now, our ball is an exception because we're always seeing the outward face. Now, if we're inside of it, we wouldn't be able to see the inside of it.
Precisely.
You're never going to see it anyway, so that one's okay. But the problem that we have here is with cloth, especially a pendant flag that's going to be waving in the breeze, it's completely possible at some point that the flag's going to kind of bend over itself or flip over, and you would see the back faces.
Sure. Well, I mean, if it's in the middle of like a park or an open area, you could view it from any angle that you like. And so you're going to want to be able to see the back faces in some form or fashion. Right. So how are you going to solve this problem?
Well, what I have is a special material here that is using a shader that's a little bit different. With built-in Unity, we have a specular shader. Here I have a specular too.
Ooh, where'd you get that?
I've got it from the Unity site. I've altered it a little bit. I'm going to show you how to do that. But what this gives us is the ability to take this material with this new shader, apply it to our objects that before we could only see the front faces, and now we can spin around and we can see the back faces.
Nice.
Now the lighting isn't perfect on this because of just the way normals are calculated. I'm just drawing the back faces, so you're not getting true lighting and shadows. This is just so when we demonstrate exactly.
Yeah.
So when we're demonstrating our cloth, we can see both sides.
Proper lighting is going to be normal dependent. So because really all we're doing is drawing the negative side of the polygons, we're probably going to get more or less the opposite effect of the lighting that we're actually looking for.
Right. Even when this flag were to fold over itself, we'd be still seeing the back face calculated with the back face. So it would be in shadow even if the light was directly facing us, which is a problem.
Well, it's not that big of a deal in terms of just getting a demonstration of the cloth, and it is a lot better than the cloth turning invisible when it flips around. If I had to choose between one or the other, I'd choose this.
Right. There is one other thing I want to kind of do, and I'm going to break the lighting in so much that it's not going to be accurate with the scene anymore, but it's going to make our cloth show up a little bit better.
Yeah, I was wondering about that.
So I will take care of that right now. Now, back to the shader. If you want to get a two-face or two-sided shader, to accomplish it, you can either write your own shader from scratch, but that's way beyond the scope of what we're doing here. To get it, what we're going to do is we're going to go to the Unity site, and let me bring up.
Oh, you got
Unity?
Visual Studio open
Yeah,
too.
we're going to get there. We've got, if you go to the Unity site, go to their support section under Assets. If I click under Assets, down here we have built-in shaders. Here is a zip file that you can download that has all the built-in shaders. And I downloaded it, and the one that I pulled out of it for modification purposes is this normal glossy shader.
Okay.
So that's the shader that I've modified. If I double click on it, we get the Visual Studio. Don't freak out. We're not going to go in depth. I'm not going to show you everything inside of what makes up this shader. All you need to know is by default, this comes in as specular.
Okay.
I renamed it specular 2. And then I added this line, call off, right after level of detail 300. Call off is meaning to turn backface calling off. This is what allows us to see the backface.
Okay, so that line wasn't there before.
Correct.
Okay.
If we came in fresh, what you would see is this. So
now, if they didn't have Visual Studio, could they make this same edit in the Unisite editor that's
Yes,
included with Unity?
They could make it with Notepad if they wanted to.
Okay.
And any text editor they can make this change with.
Okay, just wanted to make sure.
Yep. So I just type this in. Just 2 changes to the original shader. Hit save, and then jump back into Unity. It's going to re-import because it's detecting a change. Give it a sec. And that will give you the results you want. Notice it's lit on the backside, and this is because it's not calculating the light accurately. It's a trade-off.
Sure.
So, but that's what I wanted to show you. I wanted to show you the assets that I brought in from Maya. Wanted to show you where you can get the shader, the modifications that you need to make to the shader so it renders both sides of our objects. And in the next video, we're going to build a flag.
Okay, sounds good.